Native applications are applications that have access to native platform APIs. In other words, they can access features of the operating system. Especially secure data storage is relevant here to safely store tokens. Examples of native applications are mobile and desktop apps. We're investigating how these can be integrated with OpenID Connect and OAuth in this video. I'm Ronald Guit for Duende Software, makers of IdentityServer. We help you to create secure applications in your organization. So how can a native app interact with the authorization server? A common but flawed approach is to create a login page in the application, let users enter credentials there, and send them over to the authorization server to get the tokens. While this flow, called the resource owner password flow, was supported in earlier versions of OAuth, it is now deprecated in OAuth 2.1 for good reason. The user secret should only be known at the level of the authorization server. With resource owner password flow, it is exposed in an application that might even be third party. Also, we're not getting single sign-on benefits since there's no browser that can use the session cookie set by the authorization server. Further downsides are that using federation with other authorization providers such as Google is not possible, and that the login workflow is now on the application side. Any changes would require the distribution of a new build of the application to potentially many users. Also, this pattern limits user authentication to just passwords, where often MFA or passkey support is desirable. To fix all this, a browser should be used so that the login can safely be handled by the authorization server. The browser then takes care of the front channel part of the authorization code flow and is responsible to get the code. Then the app itself can exchange the code for the tokens. And the tokens can safely be stored with native applications using the secure data storage capabilities of the platform. Some kind of embedded browser platform component could be used that can display a web page, often called a web view. Although often used, this is considered an anti-pattern because the component is controlled by the hosting application. It could, for example, read keystrokes or inject malicious JavaScript. And besides, it still doesn't give us single sign-on functionality. Also, users won't be able to use browser extensions such as password managers. A better option is to use the system browser, the default browser of the operating system. That is shared across applications, so single sign-on works while users have access to the browser features they are familiar with. Every mobile operating system provides a special version of the system browser hardened for authentication purposes. But there's a problem we still need to solve. Authorization code flow works with a redirect URI that the authorization server uses to call back to the application. Web applications live on a specific URL, but the native application doesn't. So what do we use as the redirect URL? The solution lies in the fact that URLs can be associated with an application in operating systems. You probably are familiar with this. When the Reddit app is installed on your phone, for example, and you access a Reddit link in the browser, the app automatically opens. We can use that in native applications by registering a custom URL with the operating system when the application is installed. Let's say it's app.example.com/cb. Then the authorization server is configured to accept that URL as the redirect URL. When the authorize endpoint is called, it is passed in, and when the front channel completes, the code is returned using it. Now the application will automatically open if it isn't already, and the code can be accessed by the native app, after which it can exchange it for tokens using the token endpoint without needing the help from a browser. The best way to associate URLs is by letting the app claim a URL like I used in the example. Alternatively, a custom scheme can be used, for example com.example.com. Here's the location of a code example using this workflow. In this .NET MAUI app running in Android, when the login button is pressed, we can see the system browser. Chrome in this case is opened and the login page on the authorization server shows. After entering credentials, the browser sends the code to the app and the app receives the access token with which the API can now be accessed. With a little help from an open source package, Duende.IdentityModel.OidcClient, .NET MAUI supports OpenID Connect. In MAUIProgram.cs, a class in that package called OidcClient is configured and put in the dependency injection container. Its configuration is very similar to the OpenID Connect handler we use in ASP.NET Core web applications. We see authority, client ID and scope, and a redirect URI which is using a custom scheme. It is registered with the operating system when the application installs. The class Web Authentication Callback activity associates the MyApp scheme to this application. Back to OidcClient, the browser property points to a class that implements the iBrowser interface. In its invokeAsync method, the static web authenticator is used to create a request to the authorized endpoint. The start URL is pointing to the authorization server, the end URL is the redirect URL. This call will take care of executing the complete authorization code flow, front and back channel. It returns a browser result object that is constructed using the callback URL. Now in the UI with the login button, OidcClient is injected and login async is called on the object. The access token can be read from the returned object, and when the API is called, it is included in the authorization header. Finally, a word about token management. As said, to protect tokens, they should be stored using secure data storage provided by the operating system. For example, using Keychain on iOS or Android, or DPAPI on Windows, which most of the time supports additional layers of security like biometric checks. And just like in web applications, refreshing access tokens can be automated using client libraries. The before mentioned package Duende.IdentityModel.OidcClient has that functionality built in. Also keep in mind that refresh tokens should be revoked when they are not needed anymore. For example, when users explicitly log out, or when the application is uninstalled. Client libraries, like the Duende one, have support for that too. Hope this helps. Thank you for watching.